Okay guys, welcome to my video, and in today's video I will be revising with you step-by-step science paper 2 GCE for 2020 up to the point where you will be able to go out there and answer exam questions by yourself as I do. If you are new to this channel, you are most welcome, and on this channel I teach science, biology and mathematics, and also revise past exam questions like I'm doing now. At this point I will not ask you to subscribe to the channel until you watch the video and see by yourself the value in subscribing to this channel. As I promised in my previous video that I am going to pick a winner who is going to comment and subscribe to the channel, and that person who is going to win, I'm going to send to that person actually the mathematics pamphlet paper with the solved exam questions paper. Now so I'm at the website called pickawinner.com, and I've gotten the URL of the video that I posted on my YouTube channel, and I'm posting the link here. And after posting the link here, I'm going to fetch a winner now. So it's going to say select a filter you would like to use. So I'm going to say continue here. So it is going to continue here, and then it is going to select. Then here it's saying loaded 2 comments here. So then I'm going to say pick a winner here. So it is going to pick a winner from the 2 comments that people that commented here. So okay, so congratulations to you. It says Alan Ngandu, you have won yourself the pamphlet for mathematics. Alright, congratulations to you. I'm going to send to you the mathematics pamphlet, and what you are going to do now, Alan, for you to receive that mathematics pamphlet is you are supposed to send me an email using this account. I believe you have a Gmail account having this name here, so I'm going to leave my email in the description. So what you are now going to do, Alan, is email me your account in my Gmail so that I'll be able to send it to you the mathematics pamphlet. Congratulations. So thank you very much for doing this. Okay guys, let's continue with the question. Question 1a reads: a sample of a pure compound is heated until it is completely molten, and the compound is then allowed to cool until it is completely solid again. The graph shows how the temperature of the compound changes with time. So this is our graph here, showing the change of temperature of the compound with time. As time was passing, the temperature was changing, and this is the graph which is showing that the temperature was decreasing, and then it went constant, and then it started decreasing. So the vertical axis represents temperature in degrees Celsius, and the horizontal axis represents time in seconds. Then the question says, which of the following shows points when the compound exists in both liquid and solid states? So when you look at this graph, from N to O, the temperature is decreasing. So when the temperature is decreasing, there was no change in state, or there is no change in state. But when you look at point O and P, the graph here is almost constant. So temperature is constant here, it is not decreasing as time is passing from this point. So when temperature is constant, expect change of state to be occurring. And since this compound was first heated until it was molten, then the compound was allowed to cool until it is completely solid again. So when it was cooled here, you expect it to start losing temperature, or to start losing the heat, and the temperature to start decreasing. So when the temperature started decreasing, it reached at this point when it started changing from now molten, which is liquid form, to now solid form. So from point O to point P, this compound here existed in solid and also liquid state. So our answer here is supposed to be OP. So from O to P. Okay. So let's continue to question 2. A2 reads: the diagram below shows one of the methods used to separate mixtures. So we have here clear solvent. Alright, then we have a beaker here which contained some mixtures which were being separated, and here we have some residue remaining here, and here we have this clear water coming out, or clear solvent coming out, leaving some residue here, some dirty substances here. So let's look at the question. The above method is A, chromatograph, no. Crystallization, no. C, decantation, yes. So this method above here is decantation. It's a process by which solid particles which are insoluble are allowed to settle at the bottom, and then the clear solvent at the top of the solid particles that have settled is separated separately. All right, so this is C, which is decantation. So let's go to question number 3. Question number 3 reads, which gas is not obtained on large scale by fractional distillation? Which gas is not obtained on a large scale by fractional distillation? So when we look at ammonium, no, ammonia is obtained by the Haber process. So it's not obtained by fractional distillation. So let's look at argon. Yes, since argon is found in air, so it can be obtained by fractional distillation of liquid air. Nitrogen also can be obtained by fractional distillation of liquid air, as well as oxygen. So our answer here is A, ammonia. Then let's go to question number 4. Okay, question number 4 reads, a mixture of salt and iodine crystals was heated for 20 minutes as shown in the diagram below. So there's a mixture here of iodine crystals which was heated here for 20 minutes as shown in the diagram below. Then what is Ra and Ac? So after it was heated for 20 minutes, so what we are seeing is some particles are clinging to the funnel here, all right, or attached to the funnel here. So they underwent what process here? Sublimation, where you heat substance and then the substance changes directly from solid to gas and it clings to the walls of the funnel here. So then they're asking us to identify substance R and also S, or they want us to know what R is called and what S is called. So what is R? This here, and what is S? This one here. So R is a sublimate, something that has undergone sublimation, we call it a sublimate. Then S, which has just remained here, we can call it a residue. So there were some residue in iodine crystal, a mix of salt and iodine crystal. So what remains, we can call it a residue. So we can say R is sublimate, sublimate, and AC is residue. Yeah, so our answer here should be B. So let's go to question number 5. Alright, question number 5 reads, graphite and diamond are allotropes of carbon. Which of the statements below gives the correct meaning of the term allotrope? So okay, so before we answer this question, so you need to understand what it means by allotrope. So allotrope is the existence of an element in more than two structural form in the same physical state. So it can be in a solid, but in that solid that substance exists, you may find that it contains different structural representation. All right, yeah, so that's how these allotropes of carbon and allotropes of carbon exist, like graphite and the diamond. So let's look at the options provided. A, the existence of two or more atoms having the same number of protons but different number of neutrons. So, no, this is an isotope. Then B, the existence of different forms of an element but in the same physical state. Yeah, this one sounds credible. Let's look for the second one. C, they are giant structures formed from a network of carbon atoms. These are macromolecules. Yeah, they're talking about macromolecules. This is just defining macromolecules. So giant structures, macromolecules. Then D, compounds having the same molecular formula but different structural formula. No, this is just describing isomers. So this, the correct answer here is B. So 6, let's go for 6. The table below gives data about 4 substances. Which substance has particles in a disorderly arrangement at room temperature? So the table below gives data about 4 substances. Which substance has particles in a disorderly arrangement at room temperature? Alright, so let's look at melting point in degrees Celsius and boiling point in degrees Celsius. So M, we are told this substance has a melting point of around negative 114 degrees Celsius and also a boiling point of around negative 80 degrees Celsius. So when you look at this question where they are saying which substance has particles in a disorderly arrangement at room temperature, so you need to look at this word room temperature. So room temperature is around 25 degrees Celsius. So 25 degrees Celsius is the room temperature. So now when you look at this substance here with the melting point of around negative 114 degrees Celsius, so at 114 degrees Celsius this substance would have started melting and going into liquid state. Alright, so and as it turns into liquid state at around now negative 80 degrees Celsius, this now substance starts boiling and turning into gaseous state. At this point it is already in gaseous state. Alright, so as you continue heating or as the temperature increases, or rather you expect this substance with this high temperature to be already in what? In gaseous state. At 25 degrees Celsius, this substance is already in gaseous state because at negative 80 degrees Celsius, it's turning now into gaseous state. So around this 25 degrees Celsius, it is already in gaseous state. Unless if you don't understand the negative numbers, the way they are read. So the bigger the negative number is, like here it is negative 114, the smaller it is. So this negative 80 degrees Celsius is bigger than what? The negative 114 degrees Celsius, because it is on the left. When you look at the number line, this negative 80 is on the right and negative 114 is on the left. So numbers on the right are bigger than the numbers on the left. And when you look at 25 degrees Celsius, is also bigger than 80 because the 25 degrees Celsius is on the right of negative 80. So if at negative 80 this substance is already boiling and turning into liquid, so you expect it at 25 degrees Celsius to be already in gaseous state. So we have 3 states of matter: solid, liquid and gas. And from the theory we know that the particles of a substance in gaseous state are in a disorderly arrangement, or they move in a haphazard type of motion or random motion. That's what it means by this term disorderly. So we expect here the answer to be definitely A. So we will not waste time to discuss this, but the answer is A. So let's go to question number 7. Question number 7 reads, at which temperature does a concentrated aqueous solution of sodium chloride begin to boil? At which temperature does a concentrated aqueous solution of sodium chloride begin to boil? So we are told a concentrated aqueous solution of what? Of sodium chloride. So since it is an aqueous solution of sodium chloride, you expect it to be a mixture of water and sodium chloride. Alright, so since it is a mixture of water and sodium chloride, so we don't know exactly the boiling point for sodium chloride, but what we know is the boiling point for water, because this sodium is dissolved in aqueous solution, which is water. Aqua from water, aqua. Alright, so we know that the boiling point of water is somewhere at 100 degrees Celsius. Alright, but since it is a mixture, we all know that when water is not pure, its boiling point is likely to decrease. So since water now here is not pure, it is mixed with sodium chloride, its boiling point is going to increase somehow, but not very sure. So these 100 degrees Celsius won't be the answer, and 10 degrees Celsius won't be the answer, because we expect the temperature at which water is going to boil to decrease a bit. So it could be 99 degrees Celsius or 98 degrees Celsius. For me, I went for the one which was close to 100, which is 99 degrees Celsius. So let's go to question number 8. Question number 8 reads, to determine the concentration of an acid, Elena titrated hydrochloric acid against potassium hydroxide solution. She used 25.0 cubic centimeters of 0.2 mole per cubic decimeter potassium hydroxide. If she started titrating from 0.7 cubic centimeters and reached her end point at 36.2 cubic centimeters, what is the concentration of the acid? So alright, so you need to understand, guys, this term titration here. So titration is a volumetric analysis method used to determine the concentration of a known substance. So that's why here the question says, what is the concentration of the acid? So in this question, there are two things which are reacted, alright? So we have hydrochloric acid being reacted here, hydrochloric acid, which is written as HCl aqueous. So since it is an acid, it is in aqueous, then plus also potassium hydroxide solution. So plus potassium hydroxide solution. So it is in aqueous as well. So when these two are titrated or are reacted, they will produce what we call sodium chloride. So potassium will react with the chlorine here to form sodium chloride aqueous. Then the hydroxide and the hydrogen here, they will react to form water. So this is a neutralization reaction which involves an acid reacting with a base, in which they form a salt and water. So now, to answer this question, you have first of all to put a mole-to-mole relationship using stoichiometry. So according to stoichiometry, you are supposed to say number of moles of hydrochloric acid over stoichiometric mole ratio. The stoichiometric mole ratio is the number of moles of a substance in a chemical equation. Like as you see this hydrochloric acid here, in front of it here there's 1. Or we can say, since we only have this here, no number here, it means we have 1 mole of hydrochloric acid. And so this is read as number of moles of hydrochloric acid over stoichiometric mole ratio, which is 1 here, is equal to number of moles of potassium hydroxide over also stoichiometric mole ratio here is also 1. And you know that anything divided by 1 is itself. So the number of moles of hydrochloric acid divided by 1 will get the number of moles of hydrochloric acid, which will be equal to also number of moles of potassium hydroxide divided by 1. It will give us the number of moles of potassium hydroxide. Okay, so here in this final equation of ours, it means the number of moles of hydrochloric acid is equal to the number of moles of potassium hydroxide. It is important because when you look at the question here, it says what is the concentration of the acid. So for you to know the concentration of the acid, you need to know the number of moles of the acid and also volume, as you are going to see very soon when we look at this formula which we have here. Okay, so you know that here she used 25.0 cubic centimeters of 0.2 mole per cubic decimeter of potassium hydroxide here. So you are given volume and molarity. This is molarity or concentration. So from these values of potassium hydroxide here, you are given volume and molarity. You can calculate the number of moles of potassium hydroxide. and put it here, and that number of moles of potassium hydroxide will be equal to the number of moles of also hydrochloric acid. And then you use the concentration formula here, which says concentration is equal to number of moles over volume. All right, now here, since we are given volume and what molarity or concentration C here, this one number of moles, this one volume, we need to find first number of moles of what? Of potassium hydroxide using the same formula here. So we'll make N the subject of the formula, where we are going to say N is equal to concentration times volume. And we know that concentration is 0.2 mole per cubic decimeter, and we know that volume is 25.0 cubic centimeters. So this is not the actual volume used, the SI unit for volume used when doing calculation to do with the concentration. You need to convert this one into cubic decimeters. So in our formula here, we'll say number of moles here is equal to concentration, this one here, times this 25 here. Now we are saying times 10 to the power negative 3. So this 10 to the power negative 3 simply is a conversion we are using to convert 25.0 cubic centimeters to decimeter, because you know that 1 cubic, we cannot go ahead with this. I'm unable to use this thing to write. So just know that 1 cubic decimeter is equal to 1000 cubic centimeters. So if you were to convert this, you just say 25 divided by 1000. And this 1000 can also be written as 25 divided by 10 to the power 3. Using laws of indices, this can also be written as 25 times 10 to the power negative 3, which I've actually done here. So now you are going to evaluate this. 0.2 times 25 cubic, 0.2 times 25 times 10 to the power negative 3. When you evaluate this one, you get number of moles is equal to 0.005 mole. So this is the number of moles for what? For potassium hydroxide. We have calculated because we have used these values here for potassium hydroxide. So now we know the number of moles for potassium hydroxide, and this number of moles is for potassium hydroxide, which is also equal to the number of moles of hydrochloric acid. So at this point now, we are going now to calculate the number of moles of hydrochloric acid. Alright, no, we are not now going to calculate the concentration of hydrochloric acid, because we know the number of moles. So we'll read again the question. So they are saying, if she started titrating from 0.7 cubic centimeters and reached her end point at 36.2 cubic centimeters, what is the concentration of the acid? So in the titration, you put hydrochloric acid in a burette. So when you put the acid in the burette and then the potassium hydroxide in a conical flask, so you begin now dropping drops of hydrochloric acid into the conical flask containing potassium hydroxide. So the volume at which the pupil started titrating in the burette, it was somewhere at 0.7 cubic centimeters. So this is the initial volume, right? And after the drops started dropping now, she reached the end point at 36.2 cubic centimeters. So from 0.7, the volume moved up to where? 36.2 cubic centimeters. That's when neutralization took place, the point at we call end point. All right, so here now we are going to get the volume. So if you subtract this, if you subtract if you subtract, let's say, if you say 36.2 minus 0.7, you are going to get 35.5. So this 35.5 is actually the volume that worked. All right, so this is the volume. So 35.5 is the volume of the hydrochloric acid that neutralized this potassium hydroxide. So at this point now, since we are saying what is the concentration of the acid, so we will use now the same formula. Concentration is equal to number of moles over volume. And we have already said the number of moles now here will be the same, because the number of moles of potassium hydroxide which we have calculated here, they are also the same as the number of moles of hydrochloric acid. So here we will put 0.005 here to calculate the concentration of the acid, and volume here we are going to put 35.5. So same equals concentration is equal to 0.005 divided by that 35 we found here. Since it was in cubic centimeters, we'll convert it as we did here to decimeter by multiplying by 10 to the power negative 3. So when you evaluate this expression, you are going to get concentration as 0.1408 mole per cubic decimeter as your concentration. So when you look at the options provided, this matches with B. So our answer is B. Sorry, it is B, not C. So the answer is B. Okay, so let's go to 9. Okay, so 9 reads, the energy level profile shows how adding substance X to a reaction mixture changes the reaction path. Okay, so we have the vertical axis here representing energy in kilojoules per mole, and then we have the reaction path as the horizontal axis. So we have reactants here that are converting into products here, and then here we are told this is the path reactants take if you don't use substance X. So we have this one here, this barrier here, we call it the activation energy barrier. So the reactants have to overcome this activation energy barrier for them to be converted into products when without the X. But where the X is added to the mixture, then reactants, they will use the smaller activation energy barrier to go to products. So what is X actually? It's a catalyst, and the catalyst is a substance that is added to a reaction to speed it up. Alright, so let's read the question. Which change occurs when X is added to the reaction mixture? A, the rate of reaction decreases. No, since here the activation energy barrier is lower than the usual one, so the reaction here will go faster, not slow. So B, the reaction, the rate of the reaction increases. Yes, it will increase. So our answer is B. So let's go to 10. Question 10 reads, when solid potassium chloride is added to water, the temperature of the liquid goes down. Which conclusion can be made from this observation? Alright, so when potassium chloride is added to water, the temperature of the liquid goes down. So what or which conclusion can be made from this observation? So they are saying A, the potassium chloride molecules split into ions in water. That's true. They can split into water. They can, but is that what is causing the temperature of the liquid to go down? I don't think so. Then B, the process is exothermic. No, an exothermic process is one which gives out heat to the surrounding. For example, if potassium chloride is added into the water and then the water becomes, or the temperature of the water increases, then we can conclude to say this reaction is actually giving out heat. So it's not true, since here we are told the temperature goes down. Then C, the process is endothermic. Right, an endothermic process is a process which actually absorbs heat from the surrounding and make the surrounding cool. So when you look at potassium here put into water and water becomes cool, that means that this reaction is absorbing the temperature from the water. So this is an endothermic process. So our answer is C. Then question 11 reads, which ionic equation represents the neutralization of sodium hydroxide solution with dilute sulfuric acid? Alright, so they want an ionic equation, of which I do not have enough space here, but I'll try to explain so that you know how to find the answer. So first of all, we are going to write the balanced chemical equation for the reaction between sodium hydroxide and dilute sulfuric acid. So what we are going to do here is to write sodium hydroxide as the formula like it is NaOH aqueous, since it is solution, plus then dilute sulfuric acid, which is H2SO4 aqueous. Then these two, when they react, they'll give us sodium sulfate plus what? Plus water, because this is a neutralization reaction between a base and an acid. So it will give us sodium sulfate, this one, sodium sulfate aqueous plus water. Okay, so look, I will check to see if the equation is balanced. Sodium here 1, here 2, so it's not balanced. We put a 2 here, then excuse me, sodium now is balanced. So we'll check for water, I mean oxygen. Oxygen here is 2 plus 4 here, it's 6. When we come on this side, oxygen here is 4 plus 1, 5. So we'll put a 2 here to make it oxygen 2, then plus this 4, 6. So here 2 oxygen plus 4, 6. So oxygen is balanced. Then hydrogen, 2 hydrogen, then plus 2 hydrogen here, we'll have 4. Then when we come here, we'll have 2 times 2 hydrogen here, we'll have 4. So it is balanced. Then we'll shift it to sulfur. Sulfur here we have 1, and here also 1. It is balanced. Oxygen, we already talked about it. So this is an equation. So in an ionic equation, this splits itself a little bit. Let me try to do it for you here. So this sodium hydroxide exists like this in aqueous. Then we have a 2 here, so we'll put 2 here, and then plus this hydroxide also here exists like this in aqueous. Okay, so and then this sulfuric acid will exist like this. This hydrogen plus aqueous, then this sulfur will exist like this, sulfate ion, in aqueous, and this sodium this side will exist like this, plus in aqueous, and this sulfate also will exist like that. So I'm not using a mouse, I'm using a mouse and not a writing pad, hence so hard to use a mouse. So imagine this substance has split itself in this form, and this one has split itself in this form. So again, this also has split itself in this sodium here and this sulfate here. So what we do in ionic equation, we cancel ions that appears. So these are ions. What are ions? These are charged species. So this one is positive charge, this one negative. So these are ions, this is positive, this is negative. So these are ions, all of these. So this is generally how this will exist. So imagine this will exist like this, this will exist like this, then this one will exist like this sodium here and this sulfate here. So I'm just giving you some little bit ideas, but you will see in the next question from section B, where I've written completely the ionic equation. Because of space here, I think it couldn't be accommodated here to expand this into ionic. The space was too small. So now what you are going to do is to cancel now what the ions that are common. So you expect the sodium ion this side to cancel with the one which will be this side, the one which will be in aqueous. Then also you expect this is the sulfate ion here to cancel with this one which will be in aqueous. So here you only remain with the two hydroxide, so the 2 and hydroxide. So you have the 2 hydroxide negative aqueous plus here you remain with the 2 hydrogen ion like this, and this one was supposed to be plus. I don't know why I wrote it as negative, so it will be plus this one. Then this side, these two will cancel out and you have water, so it will be equal to water like this one, and then you put the 2 here to balance it. So generally when you look at this ionic equation now, the overall ionic equation, it looks like, is it A? Yes, though we have swapped. So this part here, when you check of it, is 2H plus aqueous. Then plus, you look at this part, which is this part, 2OH negative. So 2OH negative aqueous. Then this side you have water here. So our answer is A. Let's go to question number 12. Question number 12 reads, which of the following reagents could be used to distinguish between dilute nitric acid and dilute hydrochloric acid? So the answer is could be used. So we have A, aqueous barium chloride, then we have B, aqueous silver nitrate, then C, we have aqueous sodium hydroxide, then B, we have copper 2 carbonate. So here the concept they're trying to use is you should know which salts are soluble and which salts are insoluble, which forms a precipitate. So for example, if you get hydrochloric acid and react with the barium chloride, what are you going to form? There will be actually no reaction in my understanding, because you have something like this: barium, Ba chloride plus hydrochloric acid. From the look of things, it will stay the same, because and this hydrogen behaves like a metal here in this way, and barium is a metal, so there is no way you can have barium hydrogen, no way. So here there will be no reaction. However, if you pick, let's look at this one. If you pick, let's say, nitric acid here, which is HNO3 plus, let's just pick the first one here, barium, which is B chloride 2. When we pick this, what is it going to form? It will form what we call barium nitrate. So this one will give us something like barium nitrate. So this one will be in the brackets and the 2 here. Then also, and also this one, chloride plus that one, you have some acid, I think there, something like that, hydrogen chloride. It can be some form of gas here. So this is what you can have, and this one is soluble. Barium nitrate is soluble, so it will be in aqueous. So then let's try to pick this one, hydrochloric acid. So here in the first one, when you pick hydrochloric acid with barium, there will be no reaction. So again, in the second one, when you pick nitric acid, you react with the barium, there will be a reaction in which it will form barium nitrate and some hydrogen chloride here. So if we pick this one here, where we'll say, let's say hydrochloric acid this one here reacting with silver nitrate. So silver nitrate is Ag, then NO3. So these, when they react these, you are going to have something like what's this one you are going to have? You are going to have no, there will be no reaction that will occur here, because, or you can have, you can have silver chloride. You have silver chloride plus something like hydrogen plus this one like hydrogen NO3. Yeah, that's what you are going to have. So this one will pick on this one will pick on that one. So it may form water and also some nitrogen dioxide, not as this one I've indicated here. Yeah, but what we are interested in is in this substance here. So this substance here is silver chloride, which is a solid, a precipitate. So it will form a precipitate. So when you get, let's erase this. So when we get now nitric acid by the same silver nitrate, let's see what will happen. So nitric acid is HNO3 plus this one silver nitrate, which is AgNO3. So this one will not undergo any reaction, because this one is silver nitrate. You've seen this is silver nitrate, and then this one is silver, this is silver nitrate, yes, silver nitrate here, and this one is nitric acid. So even if they will exchange, they will still form the same substance. This one comes here, this one comes here, they will still be the same substances. So there will be no reaction in this one, there will be no reaction. So what are we saying? When you pick a hydrochloric acid, a precipitate, you react it with this one, a precipitate will be formed, which is silver chloride. So hydrochloric acid is this one, plus silver nitrate, this one here, you form this precipitate, which will be seen in the solution reaction. But when you react this and this, there will be nothing that will be noticed. So you'll be able now to tell this is what is going to be able to tell or distinguish, because the question is you distinguish. So you can distinguish now here that when you react dilute nitric acid with silver, there will be no reaction that will be there. But when you react hydrochloric acid with silver nitrate, there will be a reaction where a precipitate will be formed in solid. So the answer is supposed to be B. Then 13 reads, an aqueous solution of compound X reacts with sodium hydroxide solution to form a green precipitate. When aluminium foil is added to the mixture and then warmed, a gas that turns temperate litmus paper blue is given off. What is substance X? So what they are saying is this substance compound X here is reacted with sodium hydroxide to form a green precipitate. So this is just the main function, the main one which will help us. So we will look at these: ammonium nitrate, copper 2 chloride, iron 2 nitrate, and iron 3 nitrate. Which one, when it reacts with this, will give us a compound which is green precipitate? So usually it is just C. So when you react like this, iron 2 nitrate with sodium hydroxide, it will give you a precipitate, because it will give you something like this. So you get sodium hydroxide like this. Sodium hydroxide plus this one iron 2 nitrate, which can be like this. So when these two react, definitely you expect three things to be formed. So there could be something like it will give you like this one will form sodium nitrate, so there will be some sodium nitrate if not mistaken. Then there will be some iron here, and there will be some water. There will be some water. So this iron is greenish in color. It will turn the color now green. You see this green precipitate. So that's actually why you'll be seeing that green. So the answer is C. Then let's go to question 14. 14 reads, the position of 4 elements are shown on the outline of... Okay, let me read again. The positions of 4 elements are shown on the outline of part of the periodic table. Element X has a high melting point and is a good conductor of electricity. It forms sulfates X sulfate and X2 sulfate, like X2 sulfate like that. Which element is X? So when you look at this element here, where they're saying element X has a high melting point and is a good conductor of electricity. So when you look at this periodic table, you should be able to cut it in this form. A zigzag line exists somewhere here, if not mistaken. Maybe it could exist somewhere from here. Yeah, so when you go this side, you find that there are metals, and this side there are nanometals. So nanometals, again, they are classified. There are those from this line here to this line here. These ones are called transition metals, and the transition metals have two distinguishable characteristics. They have high melting point, like this one that was stated here, from other metals, and secondly, they have variable valences. So since this one can form two compounds, this X, it means it has variable valences. So in this example here, it has a valence of 2. When it reacts with sulfur, which also has a valence of 2, these they cross like that. This comes down here, so, and also this comes down here. So these two comes down to there. Then SO4. So this you put in brackets. Then this 2 comes outside here. So these 2 are common. So this will cancel and this will cancel, and it will form this substance that I've shown us here for this one. Then another one, it's this one, which has a valence of 3. So this one has a valence of 3 like this, X3 S4 2. So this valence, again, they'll swap. This one will come here, this one will come here. So you have X2 open bracket SO4, then close bracket 3. So they're swapping. This is why you are having this. So it means this has 2 valences, and an element which has 2 valences is an element which is supposed to be a transition element between this line and this line. And here we have C. So when they say it forms sulfates like this and this one, which element is X? Is actually C. Okay, so let's go to 15. 15 reads, in the laboratory, an experiment was set up as shown in the diagram below. Alright, so in this diagram we have, in this beaker, for example, dilute hydrochloric acid, and then they are setting in it a metal which is what? Magnesium. So you expect magnesium as a metal, so it is in solid, to react with hydrochloric acid, which will be in aqueous, to form what? So it will displace this hydrogen here to come where there's hydrogen here to form magnesium chloride. So it will be magnesium chloride. It will be in aqueous because it will be still like liquid form. Then this hydrogen will be removed now. It will come out as a gas, H2 gas. So this is just rough. Now you need now to balance this equation. You check magnesium here, it's 1, and here 1. You check hydrogen here, it is how many? 2. There are 2 now here, H2 down here. So here it is 1. So you come here and balance, you put it 2 here. So hydrogen 2 and here 2. Never put it down here, that will be wrong. So again you come to the chlorine. This is A aqueous. Chlorine here it's 2 because there's a 2 in front here which is being shared by these. So here when you come here also chlorine is 2. It has a 2 down here. Okay, so which means the equation is balanced. So which equation in here, because they're saying which of the following is the correct equation for the reaction in which of the following is the correct equation for the reaction in the above experiment. So you compare some magnesium hydrochloric acid, so there's no 2 here, so this one is not the one. This one MS, yeah, MS plus 2 HCl aqueous, yes, 2 HCl aqueous, yeah, plus 2 H hydrogen gas, then 2 hydrogen gas. Now put a 2 here, which is not true as we don't have a 2 here, so it's not true. Then this one Mg, this one MgS, then 2 HCl aqueous, yes, then MgCl2, then MgCl2, yes, aqueous, yes, plus 2H plus H2 gas, yeah. So our answer here is C. So let's go to 16. 16 reads, the position of metal M in the reactivity series is shown below. The position of metal M in the reactivity series is shown below. So what is a reactivity series? So the reactivity series is a list of metals arranged in order of reactivity, starting from the most reactive metal and ending with the least reactive metal. So the question is, which metal will be used to extract M from its ore? Which method will be used to extract M from its ore? So M here, when we look at M, the position of M, we have this is potassium, sodium, M, then aluminium. So M here is actually calcium, because we say posocamo, something like that. All right, even when it's not calcium, as long as we know aluminium here, going from aluminium going this way, these metals here are extracted by electrolysis of their molten oxides. So when you look at our options here, A, electrolysis of its molten oxide, yeah, so our answer is A, because they're saying which method will be used to extract M from its ore. So it will be electrolysis of its molten oxide. So the oxide of this metal will be heated until it becomes molten, and then it will undergo electrolysis to separate now the ions. All right, so our answer here is A. So let's go to 17. 17 reads, a gas X was passed over a hot solid Y using the apparatus shown in the diagram below. So there's a hot gas X here which is passed over solid Y here, alright, using this apparatus here. So here we have some lime water here, then here we have some heat provided here. So was heated, passed over heated. So this was being heated, then the gas was passed over it. So now let's read the question. At the end of the experiment, the color of Y had changed from black to pink and a white precipitate formed in the lime water. So there was a white precipitate which was formed here. What could be X and Y? So here the answer is actually no other than C. Is it C? No, it's D. Yeah, our answer is D. So solid Y changed from black to pink. Okay, it's solid Y which changed there. So the answer is D. So what you should understand here is which substance changes from black to what? To pink. It's definitely copper. Copper oxide. It must be copper 2 oxide. Copper 2 oxide is black in color. Okay, so now yeah, this is copper 2 oxide. And which gas is used to reduce copper 2 oxide? Usually it's not carbon dioxide, we use carbon monoxide. So since this one we have identified it as copper oxide and the gas should be carbon monoxide, this leaves us at this point of our answer D. So it will be like this. So say carbon monoxide gas, when it is passed there, it will react with the copper 2 oxide solid here, and then it will reduce, this copper oxide will be reduced. So this carbon monoxide will pick this oxygen to form something like leave copper oxide. So this copper will remain alone as copper. That's why the color now will change from black to pink, because color is brown, red. The color of copper is brown, red, or pink. Yeah, close to each to those colors. Then plus now carbon dioxide gas, because this carbon monoxide will pick this oxygen to form 2 oxygen atoms here. So it will be carbon dioxide here. Then this oxygen, when picked, this one will remain as copper. Alright, so this is just a justification for our answer. Then let's go to question number 18. So 18 reads, 3 reactions involving ethanoic acid are represented by the letters X, Y, and Z as shown in the diagram below. So we have ethanol, X here, going into ethanoic acid. Then we have ethyl ethanoate, ethanoic acid going into ethyl ethanoate. Then we have ethanoic acid reacting with Y here, reaction Y, showing it going into ethanoate. Then which of the following, or which of the reactions X, Y, and Z involves oxidation? So oxidation is the addition of oxygen to what? To a compound. So usually when ethanol undergoes oxidation, it goes to ethanoic acid. So this one, ethanoic acid going into ethyl ethanoate, which is an ester. This one is esterification. So when you react ethanoic acid, which is the carboxylic acid, and this one, you form ethyl ethanoate. So this process Z is esterification. Then here ethanoic acid, you react with something in Y here to give you sodium ethanoate. This is a neutralization reaction because sodium ethanoate is a salt. So Y is neutralization, then X is oxidation, then Z is esterification. So our answer is A. Alright, so because which of the following X, Y, and Z involves oxidation? Only X involves oxidation, to the best of my knowledge. Yeah. Then 19 reads, the table below shows the result of tests carried out on compound X. So we have compound X, Then they're saying the test, bromine water added, results decolorized. Then sodium carbonate added, result colorless gas evolved. So now, which one of these? So when you look at this one, COO, I don't know what compound is this one. No, equally this one, COCC. So this compound and this one are almost the same. When I come to this one which contains an OH here, this one is what we call the functional group for alcohol. Then this one, it has COOH, which we write as COOH at the end of this. So this one is a carboxylic acid. So since it has a double bond, I assume it can actually react with a salt. So this can react with a salt. So it is an acid which can react with this, I think, sodium carbonate, yeah, to form a colorless gas, I think, yeah, like this one. Then since it has a double bond here, it is able to split this bond and add bromine water to it and decolorize it. So our answer here is D. Alcohols, I have to do a research, however, I'm not too sure about this answer, by the way, but I have to find out if alcohols also can react with sodium carbonate, yeah, so that they can give a colorless gas. But for brine water, yeah, it's possible because they have a double bond here which can break and also add a bromine there. So at the moment, the best answer is D. So let's go to 19 or 20. So question 20 says butane and methylpropane are isomers. Which formula is different for the two isomers? So butane and methylpropane are isomers. Which formula is different for the two isomers? So these are isomers. So first of all, you need to know the definition of isomers. What are isomers? These are organic compounds that have the same molecular formula but different structural formula. So they'll have the same molecular formula. Like, let me say butane. So but means 4, so it will be C4. Then since C4 times 2, which is 8, plus 2, which is 10, so it will be like this, 10, if I'm not mistaken, because the general formula for alkenes is 2N is N plus, for H, then 2N plus 2. Yeah, this is the formula for the general formula for alkenes, I mean. So if this is the general formula for alkenes, so which means that, so but means 4 carbon. So if we put 4 here, it will be C4. N stands for carbon, so but means 4 carbon. So where there's N, we put 4 carbon, and here also it means 4. So we say 2 times 4, 8, plus 2, 10. So H now will be 10. So this is the formula, yeah. So this formula now, it's the one I wrote. So if you were to, let me rub this, write it in form of structural formula, it can be written in 2 ways. So we can write this one as 1, 2, 3, 4. Then we put here 3 hydrogen here, 2 hydrogen here, also 2 here, 3 also. So we can have 1 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. Then 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in structural way, it can be written like this. It can also be written like this, or so you can just write C 1, 2, 3, 4 like this. We create a branch here. And put this hydrogen. So this one will have 1, 2, 3. Again, hydrogen here. Another hydrogen here. Another one 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 here, until there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this one, you can say there are how many? Carbon 1, 2, 3, 4. So carbon 4. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me put numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. So 10 hydrogen like this. Even here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen, and carbon 1, 2, 3, 4. So, but their structural formula here, they are different, but their molecular formula are the same. So this one, its molecular formula its molecular formula is this, and this one, its molecular formula is this. So this one is methyl propane. This one is butane. Now they are saying which formula is different for the two isomers. So the one which is different is this one, structural formula. So these structural formula are different, while the molecular formula is the same. So our answer is D. So let's go now to section B. Alright, so answer all questions in this section. Write your answers in the spaces provided in the question paper. B1, the following diagram. B1, the diagram below shows the setup of apparatus used to investigate the products of a burning candle. So this is an apparatus setup. There's a burning candle here. So when it is burnt, there's some gas going here. This coming here, it is cooled, and then some gas which is not cooled comes here, and it bubbles there. Those are bubbles. Then there's lime water here, and this is ice cold water here. And here we are told there's a colorless liquid here. All right, so let's continue. So A, they are saying, why is the U-tube surrounded by ice cold water? Then B, name the colorless liquid. Then C, state what happens to the lime water in the test tube. Then D, name the elements found in candle wax. Then E, explain how you can confirm the identity of the colorless liquid. So let's start answering. So here, like A, why is the U-tube surrounded by ice cold water? So it's this U-tube here. This one is called the U-tube, and it is surrounded by ice cold water. Why? So to cool any gas which is inside here, to convert any gas which is inside here into the liquid or condense. Alright, so here the answer was to cool any gas in it into liquid. Okay, then B, name the colorless liquid. So they want us to name this colorless liquid here. So the colorless liquid here should be water. What you should know, candle here, candle, burning candle, the candle itself, it is an organic compound. So when organic compounds undergo combustion, they only form two products. They form carbon dioxide and water. This is the result of combustion. So they form this compound, carbon dioxide and water. So carbon dioxide and water both go through this delivery tube, and when they reach here, since water at ice cold water, since this vapor at ice cold water can be converted into water, so it gets converted into water here. So the colorless liquid here is water. Then state what happens to the lime water in the test tube. So here, what will happen to the lime water in the test tube? So since here it's carbon dioxide which is coming here and which goes here, so lime water turns milk, or a precipitate, a white precipitate is formed in lime water, any of those. So for me, I said changes color from clear to milk white, or a white precipitate is formed in lime water. So D, name the elements found in candle wax. What are elements found here in candle wax? So there's carbon and also hydrogen. Then E, explain how you can confirm the identity of the colorless liquid here, water. How can you identify the identity of water? So this one, how can you identify? So 1, by adding it to copper 2 sulfate or cobalt chloride. So we know when you add water to copper 2 sulfate, let me say anhydrous, Alright, here I should have put something like anhydrous. So when you add it to anhydrous, meaning dry copper 2 sulfate or anhydrous cobalt chloride, what happens? It causes copper 2 sulfate change color to blue, or cobalt chloride change color to pink. So water, when added to anhydrous copper 2 sulfate, anhydrous copper 2 sulfate changes color to blue. Or if it is added to what? To anhydrous cobalt chloride. So anhydrous cobalt chloride changes color to pink. That's how you identify the liquid as water. Okay, let's go to another question. Question BT. The diagram below represents a paper chromatogram of 3 sugars K, M, and N. So we have a paper chromatograph of 3 sugars K, M, and N here. Then they are saying A, state the most soluble sugar. Okay, state the most soluble sugar. So before we state the most soluble sugar, you need to understand by the term soluble, which comes from the word solubility, ability to dissolve. So a substance which dissolves easily is called the most soluble one. So in these 1, 2, 3 sugars, they are saying state the most soluble sugar. So how do you know the most soluble sugar? By the way it moves on the paper chromatogram. So the furthest the substance is from the solvent or from the start line here, the furthest it is from the start line, the more soluble it is. So when you check at these M, K, and N seems to be furthest from this start line, so it is the most soluble one. So the most soluble one is N. Then B, on the chromatogram above, this chromatogram here, indicate the solvent front. So these are the lines. This one is called the start line, this one is called the solvent front. So we'll say solvent front is this line here. Okay, so let's go to another question. B, C. The 3 sugars K, M, and N are colorless. What should be done to the chromatogram to make them visible? So if these are colorless, what should be done is to sprinkle a locating agent on the chromatogram to make them visible. So we use a locating agent that we apply on a chromatogram containing colorless chromatogram to make them visible. So the answer here was that sprinkle a locating agent on the chromatograph. That's all. Then here D, explain how chromatograph can be used to identify false banknotes or forged paper money. So if there's money that has been forged or suspected to have been forged, so we can use chromatograph to identify. So what can we do? We can get ink from the original banknote and the ink from the forged or suspected forged banknote and put them in the make them undergo chromatography. So as they undergo both chromatography on the same filter paper, so their ink are going to move. So if the distances they move from the start line is the same, then we can say that this banknote is not forged, it's original. But if the distances are different, then we can say the banknote is really forged. So explain how chromatograph can be used to identify false banknotes or forged paper money. So here is the answer. Inks from original banknote and forged banknote are both placed on chromatograph paper. After some time, the inks will form a chromatogram with spots positioned at different distances from the start line. I think that is it. So after some time, the inks will form a chromatogram with spots positioned at different distances from the start line. Yeah, so that's the answer here. So let's go to question 3. Question 3 reads, the grid below represents part of the periodic table. Study it and answer the questions using the letters. The letters are not the actual symbols of the elements. So here, A, we are told an element V has atomic number 7. Indicate the position of V on the grid. So which position of V will be here? Where are we going to place V? So first of all, you need to know that for placing an element like V with atomic number 7 in the periodic table, we use electronic configuration, and in such an element like V with atomic number 7, you should know that the number of electrons also are 7. So we use electronic configuration where you know that the first shell should have 2 electrons, the second shell should have 8, and the third, and like. So like this one, in its electronic configuration can be like this. The first shell can have 2. Then after we remove 2 from 7, what will remain with it? Will remain with 5. So since it has 2 shells, 2 shells, it will mean it will be in period 2. And since the last shell has 8 electrons, it will mean 5 electrons, it will be in group 5. Or if you don't understand this one, we can use this way. So we have first shell electronic configuration with 2 electrons. Then we have another shell with how many electrons? 5. So here 1, 2, 3, 4, and 5. Okay, this is how the electronic configuration is going to be. Then what you should know here is number of electrons in the last shell represents group number. So how many electrons in the last shell here? There are 1, 2, 3, 4, 5. So it will be in group 5. Then another point to know is that the number of shells represents period number. So the number of shells here, they represent period number. So how many shells are here? 1 and 2. So it should be in period 2. Now, which one are periods first? So let's start with the groups. So these vertical lines are called groups. So we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, group O, which is group 8. So we are saying number of electrons in the last shell represents group number. So there are how many electrons in the last shell? 1, 2, 3, 4, 5. So it should be in group 5 here. Alright? And this one says number of shells represents period number. So 1, 2. So it should be in period 2. So which are period? These are horizontal lines like this. So we have like this one here. Yeah, so this is group 5 where it's supposed to be. So periods, we have this one, period 1, period 2, period 3, period 4, period 5 here. These are the only ones that are provided here. So now, since it will be in period 2, 1, 2 shells, so we'll leave period 2 here. So where this line for period 2 and group 7 are going to intersect here, that's where this element should be placed here. Okay, so V will be placed there. So B, explain why the atomic radius of E is bigger than that of R. So they are saying the atomic radius of E here is bigger than that of R here. Why? So the reason is simple. When you look at periodic trains, as you move from the left side of the periodic table to the right side of the periodic table in the same period, the atomic radius decreases, simply because as you move from left to the right, the number of electrons increases together with the number of protons. And so if the number of electrons is increasing and the number of protons is also increasing, and you know that electrons are negatively charged, and protons are positively charged. So there is an attraction between protons and electrons. So since the number of electrons is increasing and the number of protons, so that attraction force also is increasing. So if that attraction force is increasing, you expect the electrons to be attracted more to the protons. So if electrons are attracted more to the protons and electrons are found in shells, you expect those shells to be pulled closer to the nucleus. So if they are pulled closer to the nucleus, then it means that the radius now of the atom now will become small. So that's the explanation behind there. So in my answer here, I had to say, because R has more electrons, so R has more electrons and protons than E. So R has more electrons and protons than E, and hence it has more nuclear attraction than E. So nuclear attraction is that attraction between the protons and the electrons. So I also said, its electrons are attracted more to the nucleus than those of E. Yeah, so here the electrons are attracted more to the nucleus than those in E. So that is the reason why E is bigger than R. Then C, which element has the highest tendency to gain electrons? So what you should know here is that metallic atoms lose electrons while non-metallic atoms gain electrons. So mostly when we make a line here, we call the zigzag line, going in this way you have metallic, going in this way we have atomic. So as you go this way, the ability to lose electrons increases. As you go this way, the ability to gain electrons increases. That's how it is. So when we compare all these, so you find that these are furthest. The further away it is, apart from those in group 8 which don't react, but these are furthest from this side, so they have higher ability to gain electrons. So when we compare these and these others here, so you'd find that this one has more ability to gain electrons than this. And since this is in another group, so it has less ability as compared to this one here, R. So the answer here is supposed to be R. Alright, let me again explain here. So in a group of nanometal like here, going up like that means more ability to gain electrons. Then going down like this means less ability to gain electrons. So when we come here, so this group is furthest, so you expect this to have more ability to gain electrons or tendency to gain electrons. But again, when you are in this group again, when you go up, so those which are up have more tendency to gain electrons than those which are down. So R surpasses these W and X. So our answer here it is R. Then D, state the most reactive metal. So when we come to metals again, so these are nanometals here. So metals are just here, A, B, C. When we come to metals, it's the opposite trend. Remember, reactivity involves electrons being shared or electrons being lost. That's what is involved in elements when they react to form compounds. And mostly metals will lose electrons. So the more easily a metal atom loses electrons, the more reactive it is. So in a group like this one, in groups, when you go down, elements lose electrons easily than when going up. So those at the bottom, they lose electrons easily, and so they are most reactive. So this one is at the bottom, is furthest, so is at the bottom. So C here is most reactive because it has high tendency to lose electrons. So our answer here is C. Okay, so let's go to another question. So question E says write the formula for a compound formed when B reacts with E. So let's see, when B here reacts with what? E. So we should know that when writing chemical formula, we use what we call valence electrons. What are valence electrons? These are electrons that a metallic atom loses, or the electrons which a non-metallic atom gains. So here, since the zigzag line is somewhere here, if not mistaken, so you'd find that this one is a non-metal. So this one will gain electrons, and this one is a metal, it will lose electrons. So now, how do we know electrons that an atom will gain or lose? So we use 8. So since this one is in group 1, all right, so it will lose its electrons, because the rule is that the less electrons you have in the outermost shell, the easily the element or atom can lose those electrons. So it's like those elements with electrons less than 4, less than 5, those atoms with electrons less than 5, they will lose them. And those elements with the electrons in their outermost shell more than what? Greater than 5, sorry. So here, let me just do it like this. So those electrons with electrons greater than 5 in their shells, they will likely gain electrons. So here, the group number, remember in the previous question, the group in which an element is represents the number of shells which is in its outermost shell. So this one, since it is in group 1, so it has 1 electron in its outermost shell. So it can lose that electron because it is less than 5. And this one is in group 1. Let's count 1, 2, 3, 4, 5, 6. It's in group 6. So 6 is greater than 5. So this we will gain. So since it has a 6, it is in group 6, meaning it has 6 electrons in its outermost shell, and it needs to gain how many more to make 8? 2. So this one can gain 2. So its valence electrons are 2. So this one is valence electron is 2 because it needs to gain 2. This one is valence electron B is 1 because it will lose that 1 electron. So these are the valences we use. Now that you understand this, so we'll write like using the symbol now. Since they're saying write the formula of a compound formed when B reacts with E. So here now you say B with a valence of 1. You put a valence of 1 here as a super subscript here. then is reacting with which one? E here with a valence of 2. So you write like this, E with a valence of 2. Then what we do is to swap around these valences so that this one comes down here and this one comes down here. Alright, so that's how we swap. So this one will come here and that one will go there. So we'll have something like this. B2, so this one 2 has come here, and then we'll have E1. So this one now we get rid of it because it doesn't make sense, because when we have just E here it means E1 already. So we'll say B2 and E. So this is the formula they want us to write. Okay, so we are done. Then we will go to B4A1, which says define concentration. Then 2 says state the SI unit of for concentration. Then 3 says calculate the mass of potassium hydroxide KOH that needs to be used to prepare 500 cube centimeters of 0.25 molar solution in water. Okay, so concentration is the number of moles of solute dissolved in a solution. Yeah, so it's the number of moles. If there are 10 moles dissolved in let's say 10 cubic decimeter, then we can say the concentration is actually 1 mole per cubic decimeter, meaning we have 10 moles dissolved in 10 cubic decimeter. So when we divide these, it will be 1, so we'll say 1 mole per cubic decimeter as the concentration. So that's what concentration is the number of moles of solute dissolved in a solution. Yeah, just like that. Then they're saying to state the SI unit for concentration. So they are mole per cubic decimeter, like this, mole per cubic decimeter. Then 3, calculate the mass of potassium hydroxide KOH that needs to be used to prepare 500 cubic decimeter of 0.25 molarity solution in water. Okay, so here what we are now going to do here, since they are saying calculate the mass of potassium hydroxide KOH that needs to be used to prepare 500 cubic centimeters of 0.25 molar solution in water. So now they need the mass of potassium hydroxide. So before you calculate the mass, you need to know the formula for calculating the mass. So the formula is number of moles is equal to mass over molar mass. So it's this mass they need. So we'll say mass will be equal to number of moles times molar mass. Then molar mass is easy to calculate. So molar mass of potassium hydroxide is found from the periodic table. So let's get this part of the periodic table. Potassium has 39 here as the relative atomic mass, 39, and then oxygen 16. Oxygen, where is it? Here, 16. Then hydrogen, it's here, H1. So when we add this, it will give us as 56 as the molar mass for potassium hydroxide. Now we need to know the number of moles here. So when we say mass times the number of moles times molar mass, this one will get the mass they are asking us. Calculate the mass of potassium hydroxide. So here we have been given volume and what? Concentration. So we can find the number of moles. So we know the formula connecting concentration and the number of moles and volume. So the formula says concentration is equal to number of moles over volume. Now we need the number of moles here. So we'll make number of moles the subject of the formula. So we'll say number of moles is equal to concentration times volume. Okay? So now, what now we are going to do here is to now make sure that we substitute where there's C concentration, we put 0.25. 0.25. Where there's a V, we put 500 times 10 to the power negative 3, because we should convert 500 into cubic decimeters. So it is going to be number of moles is equal to 0.25 times 500 times 10 to the power negative 3. When we evaluate this, it will give us the number of moles as 0.1 mole. Now we know the number of moles, so we'll substitute. We'll say now mass is equal to number of moles times molar mass, and the number of moles is 0.1 times the molar mass, which is 56. When we multiply this, we'll get mass as 5.6 grams as our answer. Okay, so let's go to another question. Please construct a balanced chemical and net ionic equation for the reaction between potassium hydroxide and sulfuric acid, include state symbols. So here we are going to write the balanced chemical equation between what? Potassium hydroxide and the sulfuric acid. So we are going to say chemical equation will be potassium hydroxide in aqueous plus sulfuric acid in aqueous. This is the formula for sulfuric acid. When the two react, they will form potassium sulfate, aqueous plus water. Okay, then we need to balance the equation here. Here we have potassium 1, here potassium 2, so we'll put a 2 here. Then after putting 2 oxygen, we'll have now 2 here, plus 4 here, we'll have 6. Then here oxygen will have 4 plus 1 here, we'll have 5. So we'll put also a 2 here, so we'll have 2 oxygen here plus 4, which will also be 6. Then we'll go for hydrogen 2, then plus 2 here 4, then hydrogen here 2 times 2 4. Then we'll go for sulfur 1 and also here 1. So yeah, everything is balanced. So this is the first chemical equation. Now they need net ionic equation. Now here you need now to know how to write the net ionic equation. So we'll split this into 2 like this. So potassium will be split here into 2. So we'll have potassium ion. Since there's a 2 here, potassium ion is a plus, because there's a nanometal here, which is radical, which is the hydroxide, and then this potassium is a metal, so it will have a positive and this 2 in front here. Then plus, since we are splitting here, plus the same one here remaining, which will have a 2 here, and also hydroxide. So the hydroxide, its charge is in negative, aqueous, so it is in aqueous. Then plus this one here, then this one sulfuric acid also will split it here, so we'll have hydrogen here as ion plus a 2 in front, so 2 hydrogen positive here, then plus, now we'll remain with the sulfate, so the sulfate ion, which has a negative here, so it will be negative also in aqueous. So we have split this one into this and this, then also split this one into this and this, then equals. So we're also going to split this one, which is in aqueous, and not split water, because water is not in aqueous. So we'll split also this one, potassium will split, so potassium 2 plus potassium plus aqueous, then plus this sulfate also, which will be SO4 negative aqueous, then plus water. Water is not going to be split, because during splitting we only split those species in a reaction that are in aqueous. Then the next step is cancelling those species that occurs on both sides of the chemical equation, on the reactant side and on the product side. So we have the potassium ion on the reactant side and potassium ion on the reactant side. So this one will cancel with this one. Then we'll check again. Here we have the sulfate ion on the reactant side, also the sulfate ion on the product side. So we'll cancel these. Then after we'll cancel, we'll remain with these. Now here we'll remain with 2OH. Then here we have 2 plus, then here we have water. So say 2OH negative aqueous plus 2H plus aqueous equals, then it will be water, like that. So this is our net ionic equation. This is how we find the ionic equation. Okay, so let's go to question number B. 5b5 reads, when excess magnesium powder was added to 100 cubic centimeter of 0.5 concentration copper 2 sulfate solution in a plastic cup wrapped in cotton wool, the temperature of the solution rose by 5 degrees Celsius. What type of this reaction? What type of reaction is this? So this reaction is what we call exothermic reaction, because what is happening is that when excess magnesium powder is added to 100 cubic centimeters of 0.5 concentration copper 2 sulfate solution in a plastic cup wrapped in cotton wool, the temperature of the solution rose by 5 degrees Celsius. So since the temperature has increased, so this reaction is an exothermic reaction. So we'll put exothermic reaction. Then we'll go to B. B here says suggest what was used to determine the rise in the temperature. So what could have been used to determine the rise in the temperature? It's a thermometer. So a thermometer. Then C, describe what was observed when magnesium was added to the solution. Alright, so when magnesium is added to the solution, you expect the color to change from blue to white, or to colorless, because magnesium forms a colorless compound, and also copper 2 sulfate will lose its color, because when magnesium reacts with copper 2 sulfate, you know magnesium is high in the reactivity series than copper, so it is going to take the position of copper in copper 2 sulfate, and that copper 2 sulfate is blue. Now since magnesium will remove copper from the sulfate to form magnesium, so the color of copper 2 sulfate will change, because it will now form copper plus magnesium sulfate. So here the first observation is that the color of the solution changes from blue to colorless. Then another observation is that the color of the magnesium changes to red-brown as copper deposits on its surface. Alright, so this one was a little bit off, because I thought it was a situation like where you have a beaker, then you have copper 2 sulfate solution here, then you put what? This is copper 2 sulfate solution, then you put like something like this as a metal. This is what happens if this is now magnesium, then this answer qualifies, but it's not like that. So what it is in this question is like this. So this is, for example, the beaker, then there's the sulfate here, this is the sulfate copper 2 sulfate, which is blue, okay. Then they put magnesium powder. So this one is magnesium powder. So if magnesium powder is put here, so magnesium powder will react with the sulfate to form something like, so you have like magnesium plus this copper 2 sulfate. This is what I was talking about, plus the sulfate. So magnesium will pick on the sulfate, this one, to form magnesium sulfate, which is colorless, plus now copper. So now this copper is a metal, so you expect it to drop at the bottom. So yeah, so according to the first answer here, the color of the solution changes from blue to colorless is true, because now this solution after the reaction, this solution here now, instead of being this after the reaction, the solution now is going to be this solution now is going to be magnesium sulfate like this. So this solution will be magnesium sulfate. Then Then copper now will come down here, so we'll have 2 mass solids of copper at the bottom here, and this copper is red brown or pink. So now the color of magnesium changes to red brown as copper is deposited on itself. No, so here the answer is now there will be some more red browny particles at the bottom of the beaker. All right, yeah, that's what the answer is supposed to be. So you say pink or red brown, so pink solids, oh sorry, pink solids, pinky solids, pink solids of copper, sorry, forms at the bottom, of the beaker. Hope you are following the way I'm just mentioning these things. Don't follow properly these because I'm unable to write properly using a mouse. So yeah, so that's how the answer was supposed to be here. Okay, so let's move to D. Why is the plastic beaker wrapped in cotton wool during the experiment? So it is wrapped in cotton wool, number one, to be able to see the color change. So to be able to see the color change of the solution, and also to be able to see the particles that will be formed at the bottom. So what I said was to ensure that the color change is observed easily. Yeah, there could be other reason, but for me this is what I think it is for. Then E, how many moles of copper 2 sulfate are present in 100 cubic centimeter of solution? So they need the number of moles. So we will bring the question, the main question. So the main question says, when excess magnesium powder was added to 100 cubic centimeters of 0.5 molar copper 2 sulfate solution in a plastic cup wrapped in cotton wool, the temperature of the solution rose by 5 degrees Celsius. So here they are saying how many moles of copper 2 sulfate are present in the 100 cubic centimeters solution. So we know first that the number of moles, okay, this is the volume and this is the concentration. So we know that number of moles is equal to concentration is equal to number of moles over volume. Then we are given volume and the concentration. So concentration, number of moles over volume. So this we are given and this we are given. So we need to know now number of moles. So we'll make number of moles the subject of the formula, which will mean concentration times the volume. Then concentration is this and volume is this. So this volume needs to be converted to cubic decimeter by multiplying it by 10 to the power negative 3. So we'll say number of moles is equal to 0.5 times 100, this one times 10 to the power negative 3, which when we evaluate will give us 0.05 moles. So this is the number of moles. All right, so let's continue to the next question. Good. Question B6 reads, greenhouse gases pollute the air. Chlorofluorocarbon CFCs are greenhouse gases. A1, name 2 other greenhouse gases found in the atmosphere. Then 2, state the respective origins of each of the gases named in part 1. Then B, describe how the presence of CFCs in the upper atmosphere increases the amount of ultraviolet light reaching the Earth's surface. All right, so here the other 2 greenhouse gases found in the atmosphere are, we can talk of carbon dioxide and also methane. All right, then they're saying to state the respective origins of each of the gases and named in part 1. So this one comes from the combustion of, so carbon dioxide comes from the combustion of hydrocarbons, and then methane comes from decomposition of vegetables. So here is supposed to be veg like this, veg vegetables, if I'm not mistaken. Yeah, vegetables. So yeah, that's where these come from. Then let's continue with the B says describe how the presence of CFCs in the upper atmosphere increases the amount of ultraviolet light reaching the Earth's surface. Okay, so these CFCs, which are chlorofluorocarbons, when they go in the upper atmosphere there, with high temperature there, they split, and chlorine actually starts reacting with the ozone. So as it reacts with the ozone, which also provides a blanket around the Earth, which shields most of the ultraviolet rays coming from the sun reaching the Earth. So ozone shields most of the ultraviolet rays from the sun reaching the Earth. But this chlorofluorocarbon, which produces chlorine radicals, these chlorine radicals react with the ozone, and as they react with ozone, they are depleting or reducing its amount, creating holes in the ozone and allowing most of the now rays, which are ultraviolet, to reach the Earth. So that's the explanation, and the short answer here is that CFCs in the upper atmosphere react with ozone, which provides a shield against ultraviolet. So this reaction depletes ozone, causing holes in the ozone and allowing ultraviolet reach the Earth's surface. Okay, so this was the answer. So let's continue to another question. B7 reads, the diagram below shows an arrangement of outermost electrons in a molecule of a compound. So okay, so this is a molecule of a compound which has bonded. Yeah, it's a molecule. Good. Then they're saying A1 on the diagram indicate a double covalent bond by putting a circle around it. Then 2, construct the chemical formula of the molecule above. Then 2, calculate the molecular mass of the molecule. So we'll start with on the diagram indicate a double covalent bond by putting a circle around it. So what we are going to do here is that we are going to look at this carbon here and this hydrogen here. So carbon has brought how many electrons here? 1. So carbon, its electrons are represented by what? By a dot. So carbon has brought 1 by a dot here, and hydrogen also has brought 1 by an X here. Okay, so alright, so these dots are not okay, they just made a mistake. They were putting also dots there. So hydrogen just contains 1, so it should have been bringing this X just here, but it seems that this dot on the middle doesn't count, so don't consider these dots on the middle. Yeah, those dots are just representing the position of the symbols of the atom. So here hydrogen contributed this electron and the carbon contributed this, so each one contributed here 1 1, here also 1 1, here also 1 1, here also 1 1. So since they contributed 1 1, so these are called single bond. Even here 1 1, even here 1 1. But here you'll find that in this overlap here, there are how many electrons here? There are 1 2 3 4. So these 2 came from this one, and these 2 came from this. So this is what we call a double bond. So we'll put a circle here to indicate a double bond according to the question, which says putting a circle around it. So B, they are saying construct the chemical formula of the molecule above. So what we are going to do here is to write C here. So we have how many C's here? So we have this C here surrounded by how many? H, H, H. So write C and put H3. So there are 3 H here. And this one also will write another C here, which is surrounded by O, O, H. So write C and O, O, H. So this is the chemical formula. Then 3. Calculate the molecular mass of the molecule. So the molecular mass is just to get here, carbon has the relative atomic mass 12 plus 12, which will be 24 here. Then plus for hydrogen has relative atomic mass, which is 1. 1 times 3, 3, plus another 1 here, 4. So we'll say plus 4. Then oxygen has relative atomic mass, which is 16, and 16 here 32, so say plus 32. Then when we add this, we are going to get 60. All right, so we are going to continue to another question. So question B1 reads, to which homologous series of compounds does the molecule belong? So to which homologous series it belongs to? What we call carboxylic acids. So at the last you saw there was a COOH. So this is a carboxyl group, which is a functional group for carboxylic acids. So 2 states says the state 1 chemical property of the molecule. So these are carboxylic acids. They have so many properties, and I decided to pull all of them so that you are assisted. So they have about 1, 2, 3, 4. So number 1 here is that carboxylic acid reacts with alcohol to form water and ester, all right, in a reaction called esterification. So number 2 is that carboxylic acid reacts with bases to form salts and water only. So in another reaction is that carboxylic acid reacts with what? Metals to form salts and hydrogen gas. In another reaction is that carboxylic acid reacts with carbonates and hydrogen carbonates to form salt, water, and carbon dioxide. So in the almost last question in section A, this is why we decided in our answer to give our answer to that question, which was like D, because D was a carboxylic acid, because in that I said a carboxylic acid will react with a carbonate and it will form a gas, and that gas was colorless, was actually carbon dioxide. Okay, so now let's go to another question here. So now we are now in section C actually. So section C, 20 marks. So it reads, answer any 2 questions from this section. Write your answers in the separate answer booklet provided. So C1 reads, clean dry air contains about 79% by volume of nitrogen. So A, name the gases which make up the remaining 21% by volume of clean air. Then B, a sample of polluted air was found to contain both nitrogen dioxide and sulfur dioxide. 1, state a major source of each of the pollutants. 2, describe a test which could be carried out to confirm the presence of sulfur dioxide in the polluted air. Then C, respiration and rusting are chemical processes which involve one of the gases in air. 1, show clearly by chemical equations how this gas takes part in each of these reactions. Then 2, one method of preventing rusting is the sacrificial protection. Then describe how this method of rusting prevention could be used in an oily pipeline and explain how it works. So okay, so now let's start answering. Okay, so here, name the gas which make up the remaining 21% by volume of clean air. So you know, here the gas is supposed to be what? The gas is supposed to be oxygen actually. So oxygen makes the 21% of the clean air. So all right, then 2, they are saying state a major source of each of the pollutants. So the major source of this one, sulfur dioxide, and this one. So the source of sulfur dioxide actually is the combustion of fossil fuel, and also the source of nitrogen dioxide is the combustion in internal engines. Okay, so nitrogen at high temperature reacts with oxygen to form nitrogen dioxide. So you know the air which enters into the engine for combustion is a mixture of gases, of which nitrogen is one of them. So nitrogen also goes into the engine, and also because the engine has got a high temperature inside there, so nitrogen reacts with that oxygen which goes inside and form nitrogen dioxide. So according to our answer here, we are going to say that, what are we going to say? So according to our answer, we are now going to say that sulfur dioxide is produced from combustion of fossil fuel, and then we are going to say nitrogen dioxide is produced from internal combustion in engines. All right, so we are going to go to C. C says respiration and rusting are chemical processes which involve one of the gases in air. So which gas is this one they're talking about? It's oxygen, actually. So they're saying part 1, they are saying show clearly by chemical equation how this gas takes part in each of these reactions. So they need the chemical equations. So they're not asking for balanced one. So we are going to say number 1, the sample of the air. So which question is missing here? Describe a test which could be carried out to confirm the presence of sulfur dioxide in the polluted air. All right, so this one we are going to say that the sample of the air suspected to contain sulfur dioxide should be bubbled through a solution of potassium dichromate 4. The color of potassium dichromate 6 changes from orange to green if sulfur dioxide is present. So this one is supposed to be U sulfur here, guys. So yeah, that's the answer for this question. Then so the other question here, they are saying show clearly by chemical equations how this gas takes part in each of these reactions. So I've already talked about this. So here we are going to say it's rusting, actually, here. So here we are going to say rusting involves iron plus oxygen plus water to give us rust itself, which is iron, hydrated iron 3 oxide. Hydrated 3 iron oxide. This is rust. So this is one of the equation. Another one of the equation in which oxygen is involved, which they are saying respiration. So respiration involves carbon 6, hydrogen 12, then oxygen 6 plus oxygen. This produces actually carbon dioxide plus water. All right, these are the equations in which oxygen gets involved. All right, then let's go to another question here. Question 2 says one method of preventing rusting is sacrificial protection. Describe how this method of rusting prevention could be used on an oil pipeline and explain how it works. So on an oil pipeline, sacrificial protection involves attaching a more reactive metal to a less reactive metal, so that because during a reaction, what happens is that electrons are transferred. For example, iron rusting. In iron rusting, which we have talked about here, electrons must be transferred from iron to oxygen and water here, and then to oxygen in these two molecules here, in oxygen gas and also in water. So electrons move from here, go here. So as they move and go here, so this form this other compound. So iron starts now rusting. So you have pure iron changing to iron 3, or changing to hydrated iron 3 oxides. So now in sacrificial protection, what we do is you get a more reactive metal which you are not interested into and attach it to this iron which you need to be prevented from rusting. So a more reactive metal now will lose its electron instead of iron, and in the process iron will remain protected, and that other metal will start now undergoing now rusting or corrosion of some kind. All right, so now according to the answer, now you are supposed to say a more reactive metal is attached to an oil pipeline underwater. Then you are going to say a more reactive metal rusts in place of the less reactive metal. This is because a more reactive metal loses its electrons easily. All right, so that's the answer. So let's go now to question number C2A, which says define an acid. B says study the following reaction scheme. So we have this reaction scheme here. Sodium hydroxide in dilute hydrochloric acid gives us solution K and water. So what solution K? What is this solution K? So sodium hydroxide plus sulfuric acid, it will form sodium sulfate plus water. Then here again we have calcium hydroxide plus nitric acid. It will give us solution L plus liquid M. So what is this solution K? So calcium hydroxide plus nitric acid, it will be calcium nitrate, and also this liquid will be water, because this is a base and this is an acid, so it will form calcium nitrate, which is a salt, and also water. Then here these resulting mixtures are also combined, mixed here, and there's a white precipitate which is formed. So here you have sodium sulfate, and here you have what? Calcium nitrate. So they will exchange again the ions. So you have sodium sulfate forming now sodium nitrate, and then you have calcium nitrate forming calcium sulfate, which is a precipitate here. So N here will be calcium sulfate, and O here will be sodium nitrate. All right. Then in A1 they are saying, B1 they are saying, give the names and formula of substances K to L. So from K up to O here, Then 2 they are saying, write the balanced chemical equation for the formation of solution L and the liquid M. So balance equation for the formation of solution L and the liquid M. Then 3 they are saying, write an ionic equation for the formation of the white precipitate N. So the white precipitate N here, include state symbols. Okay, so now that we have read, so we'll start with the one where they are saying define an acid. All right, so an acid by definition is a compound formed when the hydrogen ion of an acid is fully or partially replaced by a base or metallic ion. Okay, so when you react for example an acid with either a metal or a base, expect that hydrogen in the acid to be replaced to form what? To form a salt. All right, so this is the standard definition of an acid at secondary level. At secondary level, we say an acid is a compound formed when the hydrogen ion of an acid is fully or partially replaced by a base or metallic ion. Okay, so let's go to the next question here. So this next question will require us to give the names and the formula of substances K to L. So here we said K here, since we are reacting sodium hydroxide plus dilute sulfuric acid, so here you are saying sodium hydroxide here plus what? Plus sulfuric acid here. So sulfuric acid is H2SO4 here. So you expect sodium to go with this sulfate, so it will form sodium sulfate. Sorry, the space is small, so sodium sulfate here, then plus water here, sodium sulfate plus now water, H2 here, water, which you are told here. So now what we are going to say now, this K now, so they are formed to this and this. So this one is K, sodium sulfate. Okay, so now what we are going now to say is that K is the sodium sulfate. So K is sodium sulfate. So we are going to say K is sodium sulfate and its formula is Na2SO4. Okay, then let's go to, now we are going to L. Let's answer L. So on L here, we are told also what is reacting is calcium hydroxide and nitric acid. So we'll say calcium hydroxide goes like this. Those are brackets, so this is open bracket, hydroxide OH and the 2 here. Then plus nitric acid goes by NO3. So this one also, when they react now, this calcium will react with this to form calcium nitrate like this. Calcium nitrate, which you open brackets Na3O2. So these are brackets plus now water. So this hydroxide and this H, they'll form now water, H2O. So now this L is now this one. This is L, then this is now liquid M, this one. So L is what? Calcium nitrate, and then M is what? Is water. So here what we are now going to say is we are going to say now that now L is calcium nitrate written as K Ca open brackets NO 3 close bracket and the 2 here. Then we are saying this M here is going to be water. So M is water and its formula is H2O. Okay, so now we are going to go to another question here. We need also to name what? To name this one white precipitate. So here, remember here we are coming with now potassium and here we are coming with calcium nitrate. So here I mean sodium sulfate. So you say sodium sulfate, sorry, 2SO4 sodium sulfate plus now this one coming here calcium nitrate, which will be like this, open brackets, O3 close bracket 2. So this now sodium will pick on this nitrate, then calcium will pick on the sulfate. So this one now will form something like this. So it will form now this white precipitate, which will be now calcium sulfate. It is a precipitate because calcium sulfate is insoluble. Then plus this now sodium will form now sodium nitrate, which is NaNO3. Okay, so this is sorry, the mouse is not allowing me to write things in order. So this one will be solid, so it will appear white. Then this one will be aqueous, so it will be a solution. This one, that's why they are saying here there will be a precipitate, white precipitate, which will be calcium sulfate, and there will be this one here solution, or which will be nitrate. Okay, sodium nitrate. So here now what we have established is that solution white precipitate N will be calcium sulfate, then O will be sodium nitrate. So yeah, so in answering we'll say M is calcium sulfate and its formula is CaSO4. Then this one we are saying it will be sodium nitrate. So O is sodium nitrate and its formula is NaNO3. Okay, so now we'll continue to 2, which says write the balanced chemical equation for the formation of solution L and what? And liquid M. So here what we are going to know is that we are forming calcium hydroxide plus now nitric acid, which will give us calcium nitrate plus what? Water. So we'll balance the equation here by putting a 2 here and a 2 here. So this is the balanced chemical equation. Then 3, they're saying write an ionic equation for the formation of the white precipitate N here, include the state symbols. So here we are using calcium sodium sulfate, and here we are using calcium nitrate. So we'll say sodium sulfate plus calcium nitrate, they'll give us actually the solid calcium sulfate plus sodium nitrate. So when you look at the equation here, it's not balanced, we'll put a 2 here, then it's balanced. Now since they are saying we write an ionic equation here, we are going to split here in between. Alright, so they are saying an ionic equation, so including state symbols. So we'll split. So here we'll split this. So yeah, so what I did actually, I was cancelling out what was common. So those I never split them because I had already shown you previously how to split these. So I'm just going to write the final. So this one actually is going to cancel with this because they're in aqueous. Then also, which one is in aqueous also? This one also is going to cancel with this one. So here you remain with the sulfate, here you remain with the calcium. So here they will not cancel because they are solid. You cancel only species that are in aqueous form. So you remain with calcium aqueous here, and here you remain with the sulfate. So this is the net ionic equation they are talking about. Okay, so this is your answer. Then let's go to the other question, which is the last question. So question C3 reads, the table below shows information on some substances. So here substances we have aluminium, sodium chloride, sulfur, tungsten, wax. Here we are told conducts electricity when in a solid state. Aluminium, yes. Sodium chloride, no. Sulfur, no. Tungsten, yes. Wax, no. Melting point in degrees Celsius. Here aluminium 660 degrees Celsius. Sodium chloride 806 degrees Celsius. Then sulfur 113 degrees Celsius. Tungsten 3377 degrees Celsius. Wax around 35 to 50 degrees Celsius. Then it dissolves in water. Aluminium, no. Sodium chloride, yes. Sulfur, no. Tungsten, no. Then wax, no. Then let's look at the question. Use the information in the table to answer the following questions. A1, name two metals and give a reason for your answer. Then 2, identify a mix and justify your answer. Then B, write a chemical formula for the substance that is a compound. Then C, describe how the movement and arrangement of particles in aluminium changes as the temperature rises from 659 degrees Celsius to 661 degrees Celsius. Then D, identify the substance which with the strongest bonds and give a reason for your answer. Okay, so let's start answering. So they are saying A1, name two metals and give a reason for your answer. So we know aluminium is a metal, no doubt about it, and also tungsten. However, we need to justify why these are supposed to be metals. So metals have certain characteristics which you don't need to forget. One, metals are good conductors of electricity when they are in solid. So here, conducts electricity when in a solid state. So aluminium, yes. Then tungsten, yes. So it's only metals which conducts electricity when they are in solid state. So this one is in a solid state. Then the other reason is that metals, they are usually insoluble in water, dissolve in water. Most one, aluminium is usually insoluble, and tungsten. And also metals have high melting point. When you look at this 660 degrees Celsius is high melting point, and when you look at this 3377 degrees Celsius is also high melting point. So according to our answer here, so we'll say that the metals they're asking us are aluminium and what? Tungsten. Reason, they conduct electricity in solid state and have high melting points. Good. So let's go to part 2. Part 2 says identify a mixture and justify your answer. So a mixture here, one characteristic of a mixture is that a mixture have a variable melting or boiling point. So when you look at these have sharp, only one melting point, here one melting point, here also one, here one, but here they are saying 35 to what? To 50 degrees. So this is a characteristic of a mixture. So here a mixture is wax. So and the reason is that it has a variable what? Or a varying melting point. So the answer here is that wax, because it has a varying melting point. Okay, so let's go to another question. B says write a chemical formula of the substance that is a compound. When you look at this one, it's a pure metal, but this one is a compound. Sodium chloride is a compound which is a mixture of two or more elements chemically combined. So here sodium is chemically combined with the chlorine to form sodium chloride. So this one is a compound. Yeah, so the chemical formula they need for sodium, the symbol is Na, and chlorine, the symbol is Cl. So this is the chemical formula. So the chemical formula for sodium is actually Na. Okay, so here we'll continue to which question? Part C, which says describe how the movement and arrangement of particles in aluminium change as the temperature rises from 659 degrees Celsius to somewhere 61 degrees Celsius. So as the temperature now is rising, we are using the word rising, so the arrangement of particles, so from somewhere 659 there, when it will start melting now to what, to 660, so it will start now melting, changing from solid to what, to liquid. So you expect the arrangement of particles to be widely spaced, okay, widely spaced, because it is moving now from solid to what, to liquid arrangement. Then the movement, you expect now particles to begin moving, all right, or vibrating, all right, or moving. Particles will start now moving a little bit to and fro, yeah, because now they are going into somewhere melting liquid state. Okay, so according to the answer, what I said was that the particles begin to spread apart and vibrate with large amplitude, yeah, so they'll begin vibrating with large amplitude or move a bit from one position to the other, yeah. Then let's continue here. Identify the substance with the strongest bonds and give a reason for your answer. So with the strongest bonds, so a substance with the strongest bond, when we look at this, so the one with the strongest bond should be the one with the most highest melting point. And when you look at this, it is the tungsten. So tungsten is the substance with the strongest bonds. But wait a minute, we consider bonds to be only for compound? No, even metals have got bonds we call metallic bonds. So metals have also bonds we call metallic bonds. This is a metallic bonds, so it qualifies. So tungsten qualifies to be among these with the strongest bonds. So the answer is here tungsten, because it has the highest melting point. All right, so at this point, guys, we have come to the end of this video, and if you found value in this video, especially if you downloaded it, the best way to do is go back to the video and give it a like and also comment. And if you haven't yet subscribed to the channel, hit on that way down this video, the subscribe button, hit on it, and also click on the bell that appears next to it, guys. Thank you for watching this video. Until the other time, guys, as for now, guys, let me say bye and please, peace.